I think, confidential computing can make a huge difference for society.
Operating on large data sets, sensitive data sets have become really important, and confidential computing sort of hones in on that third pillar of controlling your data and providing security guarantees.
Welcome to the AI Confidential podcast. I'm Aaron Fulkerson, the CEO of Opaque. This is the podcast where I sit down with industry experts to talk about the promise and potential of AI to create breakout industry leaders or to disrupt current leaders. After all, whoever controls the data controls the industry. For this episode, I sat down with two pioneering industry leaders, Daniel Rohrer, VP of Software Product Security at NVIDIA, who also graduated from my alma mater, University of North Carolina, Chapel Hill, and Raluca Popa. Raluca is a professor at UC Berkeley, the co-director of the UC Berkeley Sky Lab, formerly known as the Rise Lab, and a founder of Opaque. We discussed everything in this episode, from the significance of confidential GPUs, which unlocks a variety of groundbreaking use cases for confidential AI that we discuss, and some of the exciting research that Raluca is conducting at the UC Berkeley Sky Lab. I hope you enjoyed this conversation. If you do, please subscribe to AI Confidential wherever you get your podcasts. Also subscribe to our newsletter. Buckle up. This episode is going to be a technical one, and we hope you enjoy it. Daniel and Raluca, it's a pleasure and an honor to be here with both of you to talk today on the AI Confidential podcast. Thank you so much for joining us.
Absolutely. Always a pleasure to be here.
Thanks for organizing.
I like to start this conversation off when we do this podcast with a real basic general question. And we'll start with Daniel. Would you describe confidential computing in your own words and then share your high-level point of view on the significance and importance of confidential computing?
Confidential computing for me is really just defining that third pillar of sort of confidentiality and securing a data workload. We've always had sort of data at rest, data in motion, but data in use has always been a more challenging hurdle to overcome. And, in this era of like large data, large compute demands, operating on large data sets, sensitive data sets have become really important. And confidential computing sort of hones in on that third pillar of controlling your data and providing security guarantees around operational uses of data that are so endemic in everything that we're doing today in enterprises. Is it important now? I think particularly important just because of the huge growth and certainly that targeting the GPU space that we live and breathe in here at NVIDIA. It seems like the right tool at the right time to satisfy a lot of those demands.
I agree with Daniel's definition. It really is about encrypting and protecting data in use as opposed to only in transit or at rest in storage. In my mind, I also connect confidential computing with a specific type of technology, the hardware enclaves, as opposed to, for example, cryptographic computation, like secure multi-party computation or homomorphic encryption. And hardware enclaves are a very powerful primitive that, to some extent, offer the abstraction of computing on encrypted data from the perspective of software outside of the enclave, perspective of data in memory is encrypted. But at the same time, it is much, much more efficient than the cryptographic counterparts. In terms of importance, oh my goodness, exactly like Daniel mentioned, it's extremely powerful in protecting sensitive workloads in all kinds of workloads for data analytics, for machine learning, these days for Gen AI.
So, Daniel, speaking of hardware enclaves, these have been available, confidential computing and hardware enclaves on CPUs for 7 or 8 years. But NVIDIA introduced the very first GPUs with hardware enclave support and confidential computing support. This is a real game changer, particularly around AI workloads. Can you talk about this exciting new capability that you guys have brought to market and what you expect to see from industries in their use of it?
Jumping off from where we started, I think we all saw sort of the huge inflection point of data and demand and compute. And, one of the things that we're always looking at is how do we add more value to sort of that exchange, and how do we make GPUs more useful to the common workloads that enterprise are approaching. And when we see this huge data lift, also came a lot of data risk. And customers and partners were trying to understand, well, how do we manage this, especially when we maybe take it from a data center, which we had a lot of confidence and had to move it to the cloud because we just needed that much capacity. And we literally couldn't do it on-prem or sort of within the constraints of our normal operating environments. And bringing confidential computing was really just a very deliberate action of observing this challenge and demand from our partners in the ecosystem, saying, hey, what tools can we bring to bear to help solve for this problem? GPUs have been sort of well positioned to be sort of the most cost-effective and efficient solutions for data compute at scale, but that turning that privacy corner, especially for regulated markets, whether it's financial or medical or some of these others, was really a hurdle for a lot of organizations in getting and gaining those efficiencies. So removing that barrier to allow those sort of workloads to come to the GPU platform has been, I think, really transformative. And then you add on top of that sort of the AI demand, which has made access to classes of data that used to be very expensive or sort of low value now are much higher value, much more approachable. And you're just compounding that demand for data and compute, which makes GPUs such a profound opportunity, especially when you bring CC as a tool into that mix.
And what's impressive about the technology, starting with the H100 onwards for the enclaves, is that it really is very efficient. Like the security mechanisms, the enclave mechanisms are really efficient. If you look at, the very first enclaves that we had with IntelliGX, which was, pioneering enclave, I was, very fortunate to be able to access it sooner in the RISE lab at UC Berkeley before it was commercially available. But overheads there were, 50% initially, depending on the workload, could be more, could be less. But really the H100's overheads are much less than that. And it seems like going forward, overheads will be even less. So it becomes like there's no strong reason not to use this going forward. Security, it provides that it's very powerful, it enables applications, and there really isn't there's a very small performance overhead. So really no reason not to use this going forward.
Well, and I think, referring to your observation around like FHE and some of those other privacy methods, which were very computationally expensive. And don't get me wrong, we love computationally dense problems on GPUs. They work really well, and you can do FHE on GPUs. But recasting your application into an FHE context or refactoring an application to fit in an SGX enclave model was actually a lot of work. It itself was a very big barrier. And when we delivered H100 and confidential computing to the market, you didn't have to change any of your CUDA code. It just worked. You had to add some attestation and some deployment organization, but you didn't have to go and remaster an entire application stack, which for the latest generation of confidential computing enclaves is just a profound enabler, again, for those workloads and those critical use cases. They don't want to spend time rethinking how to do the computation. They just want to do the computation in as secure and efficient a way as possible. And all of that is just laid out for them with the CC model today.
And I agree that is really key to a mass adoption of these enclaves, because non-experts, they're experts in their business, right? They don't want to have to acquire security expertise or security personnel, and they want to just be able to, and they want to just use their pipeline unmodified, or as much as possible unmodified, to run on these confidential computing frameworks. And I completely agree with you. FHE, you have to, rewrite your application. It's really a lot of work for, a lot of systems out there who are not, people don't have the resources to do that. But even then, it's very slow. It's still very, very slow. Even with, GPU amplifying the performance of FHE is still very, very slow. And something that people don't think about is also you don't quite get the same security guarantees in that enclaves have this very nice primitive remote attestation that enables somebody like a user or a client remotely to know what's running on the enclave system and have some sort of assurance when they get the response, let's say response from a prompt, response like a model that was trained. But with FHE, it's something we in security call, semi-honest. Basically, there's no guarantee on integrity whatsoever. So even in security, it's not really the same guarantee. So I would say today, in industry, in real-world applications of Gen AI, of more complex analytics, really just confidential computing through enclaves is really the only practical approach.
I mean, the name confidential kind of undersells all that you get in the package. Attestation is not often talked about, and some of the collaboration models that you can enable through attestation and attestation privileges are certainly very interesting as well. When you look at confidential computing across sort of an ecosystem perspective.
Yeah, the point you make about attestation is one that we find to be the most compelling feature for Opaque when we're doing attestation around data that's being used in confidential AI workloads or for models that are being used in confidential AI workloads. But speaking with Mark Rusinovich, the CTO of Azure, He's very excited about the use of attestation across the entire software development lifecycle for attesting software package builds to prevent malicious code from being injected into packages. And then on another episode with Mark Papermaster, he was talking about using confidential computing attestation as part of the hardware supply chain, attesting the manufacturing of chips to ensure the prevention of malicious bad actors injecting backdoors into hardware.
Absolutely. And like Daniel says, remote attestation enables not just confidential computing, but confidential collaboration as well. And we've seen a lot of use cases across, wanting to collaborate across data silos of sensitive data. How do we bring them together to learn from them, to do analytics, and really confidential computing helps with that.
I'll ask another question to you, Daniel, that you can kick off. What are some of the pressing privacy and data governance challenges that organizations face when integrating AI? Like we're talking more specifically to AI here. Obviously, you in your position at NVIDIA have a unique vantage point on this topic. And then as an add-on question, has generative AI changed that?
I think generative AI, just as a focal point, has amplified a lot of concerns that probably already existed before. But, one of the ones that I feel very keenly, inside my own enterprise, but also seeing echoed throughout the ecosystem, we look at sort of the classic LLM and RAG pipelines and just accessing your data, making it more useful. LLMs had substantially lowered the barriers rather to processing lots of unstructured data and sort of extracting substantial value out of that. But as a consequence of that, a lot of organizations are sort of diving deep into data, deep dark corners of their data inventories that they largely haven't had to address before. And there are a lot of sort of latent data controls and tagging and meta labeling and things that you've probably done with your high value data, your SAP, transactional, your supply chain, all the things that you use every day, all day, but probably didn't apply because it was low value to these other data sets. Suddenly they're very high value, but you've got this debt of data controls around it. So when you smash it all together, suddenly you're like, oh, wait, should that user have access to that data or whatever? But AI is sort of making it, yes, everyone gets access to everything all the time. And you're finding these sort of very interesting problems inside your organization around data and data controls that you thought you had, but maybe didn't have in every place that you're now touching with these systems. So we're seeing sort of very interesting dynamics coming up, both on the ingest side, but also on the access retrieve side, on the other side, all sort of being driven by this sort of transition in AI and generative AI applications inside the enterprise. And you can see sort of, again, echoes of that externally, even through product build outs into customers and user spaces where data and data privacy issues, who has rights to what subsets of data, become part and parcel and very focus on the user experience and sort of how we're interacting with these systems. You can be very casual about it and have a very wide data exposure, or you can be very deliberate sort of how you build that out. And I think there's an art that everyone is sort of in real time learning as we go through this transition of how to do that well.
That's well put. Raluca, at a recent AI Confidential event, because we actually host in-person meetups with leaders in academia, industry, and people who are building data and AI applications, you shared some of the recent research you've been doing at UC Berkeley Skylab on this topic of privacy and data governance. Would you talk about that some?
Absolutely, yeah. There's a lot of security and privacy questions when it comes to Gen AI, which is great because that's a lot of work for me to do, but also a little bit scary. Some of the major ones we're working on are how do we defend against prompt injection attacks and jailbreaking? And with that also comes how do we benchmark defenses? Because unfortunately right now it's an arms race. Defenses are only mitigations and attackers, can bypass them once they know them and, then we need more defenses and so forth. That's a major direction. Another major direction of work is how do we enable Gen AI to take advantage of confidential data, proprietary data. So how can companies ask, in the prompt, some very, very sensitive data? And this is where we use confidential computing to perform private inference. So to keep a prompt encrypted during the inference process. And so only the user that asks the question, the prompt, and gets the result, can see all that information, but the model provider should not be able to see the prompt. We also do research using confidential computing on how to enable efficient fine-tuning. So we keep the data during fine-tuning encrypted and protected at all times. And then in the extreme, we're also thinking of how to protect model weights using confidential computing, because these models are becoming very powerful. Obviously, they're very expensive to produce for many companies, but more than that, the models are getting cyber capabilities. So we need to make sure they're not necessarily getting in the wrong hands. So I would say these are two major areas of work: prompt injection, jailbreaking, and then confidential computing to secure the confidential data throughout the whole, and the model weights throughout the whole GenAI pipeline.
And maybe riffing a little on the data flows, private and otherwise. I think we're seeing a big lift to agentic flows, where we're seeing multiple connected systems, and again, sort of peeking at those attestation properties and how we can build trust between connected systems and ensure confidence in data that's transited between those systems is just, again, a layer up on top of all those fundamentals that Raluca highlighted so nicely.
I'm glad you bring that one up. ServiceNow is one of Opaque's customers that uses Opaque as part of an agentic workflow for RAG with their LLM implementation, connecting to a whole bunch of different disparate systems. And they couldn't do it. They couldn't access this data, or it wouldn't be allowed. There's no technical thing preventing them from doing it without confidential computing. The issue was having the ability to verify the privacy and the data sovereignty, and also ensure compliance with the data policies. I'm really glad you bring that one up. So we see that often, also with a performance car auto manufacturer that we've done with Accenture. It's the same situation.
And I think CC is really letting you find nicely the different roles between a data owner, the person inputting data into the system, the application owner who owns the model, maybe a private model that the user who's using it shouldn't get access to, and the infrastructure owner, and really having a very clear separation to enable all types of transactions within those structured separations is really central to easing past some of those data regulatory risks that I think a lot of enterprises are looking hard at when they deploy these systems.
Yeah, I have friends that are like hardcore Linux kernel hackers, and they're like, Aaron, I could do this with just configuring my different systems. And there's some truth to that. It would be very hard to do. It would be very hard to maintain it. And you wouldn't have attestation with a cryptographic signature from the GPU or CPU doing the data processing to ensure and provide you with the verifiability. But you make a really good point. It just got a whole lot easier to do that, and it's verifiable thanks to confidential computing. And what you just described around fine dicing it for each one of the various stakeholders across these disparate systems, like it's a big deal.
And I agree with all of that. And you also get encryption in use with, the hardware enclaves and confidential computing, protecting the data throughout this whole agentic interaction.
Yeah, this makes me think of some shared customers we have with NVIDIA that are stock and commodities exchanges that have data marketplaces for which they want to monetize data that they only have. And their partners, they cannot run their algorithms in their compute infrastructure because they've invested millions, maybe billions in the development of these models and algorithms. But one thing Raluca said earlier about protecting the weights and protecting the models, of course, then allows them to deploy their partners' algorithms in their data, protecting their data with confidential computing, where each party holds the encryption key either for the models or the data, and achieves new business models that they've never had access to before. Because their only other choice would be to sell the data one time instead of monetize it in perpetuity.
I think, and maybe I'm prefetching a future question for you. That's probably the area that I'm most excited about for CC is sort of new and novel collaboration models and business models that we can build out with these primitives that would have been very hard, or if not impossible, to navigate without it.
Yeah, you did prefetch a great question, which was, give us some use cases that you guys are seeing. Like we're riffing around this right now, but just to like plant a big signpost, I mentioned a few use cases. Where do you see this going? Like, what are you seeing today, Daniel, in use cases? And then what do you see in the future?
I think it's that separation really. Like, if you think about areas like medical, we've seen cases where, you have maybe a rare cancer type. You've got 3 samples of that institution, 5 of this institution, 9 of this institution. You can't coalesce enough data, especially in that highly regulated HIPAA space, to make meaningful inroads on sort of diagnostic utility of, ML models, whether it's imaging or other. But if you can find ways to rendezvous in an enclave context where everyone can prove fair dealing, they're all dealing from the same playbook, the same code, collaborating on the same model, they can all derive utility from it and navigate those regulatory hurdles. That's fantastic for healthcare outcomes. One of the things, Raluca highlighted earlier was privacy. There are techniques like differential privacy that you can train models under to navigate past that in a different way, but it often comes with the consequence of diluting the accuracy and effectiveness of the models. If we can find ways to keep the accuracy high and still preserve those privacy properties, that's a win-win, I think, for everyone. And we see that a lot in again, those sort of medical spaces, but you can translate that similar dynamics to financial markets. When we think about fraud and fraud detection, it's not normally the transactions at a single institution that are clearly articulate the notion of fraud, but it's transactions across, credit clearing transactions, SWIFT networks, and other things that really elevate up and lets you ask those hard questions. But you have to find a model in which institutions which would normally not collaborate, for obvious reasons, to collaborate on this shared interest along the way. We see similar shared interests around cybersecurity. You can imagine managing a power grid, right? Everyone have an aligned interest in having a resilient and robust power grid, especially where they have shared connectivity, but they don't want to share sort of demand curves because that speaks to, costs for them and giving away information to competitors that they may not want to. How do we rendezvous with that data? Can we find enclave models and collaboration models where we can really do that? And we've seen a lot of examples of where that comes up that really could be enabled by these very directly.
Yeah, well, I'm going to throw it to Raluca, but first, I want to highlight one of the things you said around data collaboration because it's a compliment to NVIDIA. We have a customer it's Riskstream. It's a consortium of insurance carriers, and they're doing data collaboration using machine learning on shared data sets that they can't see each other's data in this situation because it's their customers' data, but they're doing fraud analysis. And they deployed on CPUs. It worked. It was fast enough, but with GPUs, it is 5 to 10 times faster. And depending upon the data set, it could potentially be 20 times faster. In our benchmarking with actual production data and code, it's 5 to 10 times faster. This means that it opens up a whole raft of new use cases for these companies to share data because the performance has gotten so much better. And a key point that you both said previously about homomorphic, for example, you couldn't use homomorphic for these size of data sets and these algorithms. It would not work. So thanks to NVIDIA, we're able to deliver far more value to customers and they're able to unlock a lot more value downstream from their data sharing.
And sometimes that 5x to 10x is the difference between a viable business or product, right?
Absolutely.
And I feel like we should be able to do better than that, maybe 20x. Let's work on that.
It depends on so this is what other people at NVIDIA said is why isn't it 20x? And I said, I think it's the data set size. It's the data set size. But Raluca, let's throw that same question to you around exciting use cases you're seeing today, and then where do you see it going over the next years?
I really agree with the use cases that Daniel mentioned on the medical enabling, helping medicine, because we can now put together data from different hospitals or organizations, also enabling on the financial side to detect human trafficking, financial forensics when financial institutions cannot share data with each other. I think those are amazing. And when we started Opaque, 4 years ago, started working on it, sometime before it, really these use cases were what, and up to today, when I wake up in the morning, really motivate me. I think, confidential computing can make a huge difference for society, can enable better medicine, can help, find crime. So I think these are extremely motivational. Besides this, there's a lot of other very, very useful ones. For example, one that I'm also excited about is the ability to do private inference, meaning that the model provider doesn't have to see your prompt. Well, this opens the doors to companies using Gen AI for their internal proprietary, development, using Gen AI on their IP code, on, trade secrets and whatnot. And this can really enhance productivity of many businesses enormously. Now, similarly, bringing that closer to the user, as in the future, I imagine Gen AI would be embedded in a lot of the applications we deal with, right? So we don't have all these different chores. We'll handle our email, we'll handle our messaging, we'll handle ordering food and whatnot. But that's a lot of sensitive data we're talking about, and a lot of personal data. So that's another place where confidential computing can really enable this application by protecting your data. It's really, locking your data to unlock its use.
Yeah, so speaking of private inference, Raluca, this is a great point you're making. Today, what we're hearing a lot from our customers and prospective customers at Opaque, but most of our customers today, they're not doing private inferencing yet. Instead, what they're doing is they're doing confidential RAG implementations with Opaque. And there's highly sensitive data there. But what they do as part of the RAG implementation is before they send it in the clear to a foundation model, they're masking it using tokenization or redaction to clean up any sensitive information, but then they're sending it tokenized to a foundation model. Now, some of the research that you've conducted at Berkeley and we've seen out in the wild shows that this masked data is susceptible to re-identification attacks, and it's not a security measure that's impenetrable to new AI re-identification attacks. Could you just talk a little bit about that, because it speaks directly to the importance of private inferencing?
Sure, absolutely. So, for many years, industry and, companies in the industry use masking, tokenization, anonymization as a way to protect PII and sensitive data, but also be able to compute on it, extract the insights, do some machine learning, some data analytics. Now, we in academia for many years have demonstrated all kinds of scenarios where you can de-anonymize the data by cross-linking it and whatnot, demask it. But, industry always felt, okay, these are academic demonstrations. They take special conditions. They take an expert to do. So they continued using these techniques. Now, I would say that with Gen AI, it is much easier to demask data in many scenarios. So, for example, let's just take the example of a Caesar cipher. This is just an anecdote. You actually give to one of these powerful Gen AI models, let's say GPT 4.0, we tested this, you give just 2 paragraphs or a small amount of Caesar cipher encoded data, and it's able to spit out, telling you what the text is, or continuing generation from there, either in Caesar cipher telling you what the text is about. And this is really not just the fact that, okay, the data about Caesar cipher is available on the web and the model is trained. It really is able to understand language and how language structure works. So we were able to test masked data, anonymized data, and check that the Gen AI model was actually able to cross-link with another data set, anonymize data, and identify the people with actually very little prompting. So basically the message is that because it understands natural language and has so much knowledge already that it can cross-link with, including RAG databases, it's extremely good at demasking large class of data and de-anonymizing data. Of course, not all of it, but a large class of data. So these techniques are becoming even less helpful, even less, secure, private. And, they also affect insights a lot, because if you mask or anonymize your data, it's hard to train a model. Those masked fields could actually be very useful for your insights, for learning, for analytics. So instead, confidential computing is a much, much better technology. Why? Because you encrypt the data, and there's no way for a Gen AI algorithm to decrypt it. I mean, we have some cryptographic guarantees on that encryption, but moreover, you encrypt everything, so you can't cross-link or do this kind of attacks. At the same time, the computation runs under the encryption, so you get perfect, accurate, insights, machine learning, data analytics coming out of that. So it's just a much better technology. And I personally don't believe in masking, anonymization, and this kind of technology anymore. Now even less so.
Raluca's turning on her research hat, which is getting me all excited on the technical details. Oh.
Well, Daniel, you know what this means? This means that the only GPUs you should be using are those that support confidential computing, which I believe there's only one class of GPU with confidential computing in market today.
Absolutely. Raluca raises a number of, I think, key issues here in that, the properties of these systems that we build are really important. When you think about, and I think you said Caesar cipher, that's not really encryption, right? It's an obfuscation. Back in the Roman times, they thought it was encryption, right? But the models were trained. They've seen data sets with Caesar ciphers. They know exactly what that is. It's just another encoding standard that for models, whether it's, Mandarin, English, or, UU encode, it doesn't really make a distinction in terms of how these models operate. And two, I think that the power of generative AI models, they lower the threshold and the energy it takes to activate and see past some of these things, whether it's parsing a JSON or this sort of obfuscated code. And when we smash all that data together, we make, to your point, the de-anonymization a lot easier because the data that you needed to de-anonymize is right there. It's already in the model because you trained it that way. So yeah, I think we need to be very deliberate about what properties we hope to derive from these systems. And certainly confidential computing provides many very useful properties right out of the box that you can apply to these systems if you choose to use it that way.
Yeah, and Daniel, you said it exactly. That's really the nugget, is that these obfuscation algorithms, encoding algorithms that are not secured by academic standards, people use them because they want to preserve some properties so they can do some functionality with them.
Raluca, everybody uses them in the enterprise. Like everybody's using this as their privacy standard, and it's not, right? So,
Exactly.
I'm sorry, I interrupted you, but it's just important to point out how it's not like it's common, it's everywhere. It's universal that this is the standard.
Exactly. And the fact that, that they're using them to preserve some properties and some functionality so they can do some training or analytics. But exactly as Daniel says, well, that's exactly what the models are really good at, decoding, because they understand language, they understand how words relate to each other, and they can decode some of these and they can learn another language pretty quickly. So if it looks like a language in some shape or form, it's most likely going to be something that they can decode pretty well.
Doesn't matter if it's TCP network packets as a language or English or any other structured format. It's that is what they're designed to do.
Exactly. Absolutely.
That is the point. Daniel's point right there is it doesn't matter if it's TCP packets. It's able to interpret it. Like that
Biological
is the money
right?
quote.
Same thing.
Yep.
Yeah.
That's why encryption that's actually, has a security, guarantee that's standard, like in CCA2, sorry for the acronym. But, that's something that the models cannot, decode. Again, we have some guarantees on that, mathematical guarantees on that.
All right. So Daniel, let me ask you, you've been at NVIDIA for 25 years after graduating from the world's greatest university, the University of North Carolina, Chapel Hill. There's been a lot of change in the industry over the 25 years that you've been at NVIDIA. What have you seen that's changed that surprised you the most? And what's surprised you that stayed the same?
Maybe leaning into what we sort of the core of NVIDIA. NVIDIA has always been about looking at the way we deliver unique value, right, to the markets that we serve. And the thing that we've been invested in since the beginning, whether when we talk about graphics cards and sort of the very parallel computational problem presented in representing, raster and graphics that, what we were known for in the early days, 1999, when I started, that focus on dense compute problems has remained with us throughout. And AI, I think, is just the latest generation. We've had sort of 4 or 5 evolutions of NVIDIA, even in my time here, but it's always been focused on those core dense compute problems and where we add value, and also taking a long, hard look at what are the hard problems that our customers are trying to solve and working backwards from there. And I think when we think about confidential computing and AI, privacy, data control, data provenance, all of these things are endemic of that AI hard problem. And we looked at, and in fact, we're very deliberate when we looked at CC as a possible thing to add to the corpus of GPU capabilities about solving a hard problem that we're hearing directly from our customers. Like, hey, we need help with this to be able to use these capacities that we desperately need, right? So we really look at our markets. How do we lower the barriers? How do we make our technology more accessible, more valuable to all of those verticals, whether it's cybersecurity, healthcare, biologics, weather forecasting, all of these things that we can have a tremendous impact doing fundamental core compute and data science just by making the GPU available. And I think that's sort of been true throughout my 25 years, remains true, thankfully. And one of the reasons I'm so passionate about what we do every day.
So Raluca, I'm going to ask you the same question. And thank you, Daniel. I'll ask you the same question, Raluca. You did your doctorate at MIT and then joined the staff of Berkeley, where you've been director of one of the most famous computer science research facilities, Rise Lab, now Skylab. What has surprised you the most over your career, and because it's changed or hasn't changed?
I would say that, obviously the power of Gen AI has really shocked me. And I think it has shocked a lot of, AI faculty to begin with, my colleagues. And seeing them, how powerful they have become and how powerful they become, every couple of months, made me realize that we humans are really not that smart. And this really scares me for security for many reasons. One is these models are gaining cyber capabilities and will be able to break systems more automatically. They'll be able to build, can persuade humans to some extent to do certain minor tasks currently. Right now, we just have early signs. We don't have anything that's really alarming, but we have early warning signs. And then, self-improve, self-replicate. So I think that it's really important to, think holistically about security from the start. And for companies employing Gen AI, they should not have security as an afterthought. They should really try from the start to have the strongest defenses for their data, for the integrity of their compute, privacy, confidentiality, everything it takes.
Once they've lost control of their data, they've lost control of their ability to be a competitive business.
Absolutely.
And once you've lost control of the data, it's gone. There's no putting the toothpaste back in the tube. That's really thoughtful. So Daniel, Raluca, thank you so much for joining us today on AI Confidential. We really appreciate your time and your wisdom. Thanks so much for sharing.
Thank you for having us.
Always a pleasure talking with you both.
Thanks for tuning in. I can't believe how fortunate I am that I get to spend time talking to these brilliant people on this podcast. I hope you enjoyed as much as I enjoy making them. Please subscribe, AI Confidential Podcast, wherever you get them. Have a great day.